Hi, this is Mrs. Villette, and in this video I'll go over using the fundamental theorem of calculus, part 1 and really part 2. What you're looking at are the already filled in notes for this page, and I'm just going to go through them kind of line by line and explain instead of rewriting them. So the first one, if g of x is the integral from 1 to x sine of 2t dt, calculate g prime of x. The thing that we need to remember is that the fundamental theorem of calculus part 1 says that this area so far function, and actually this should be an integral from a to x, if I do the integral from any constant, a value, to a variable x of some f of t dt, so we remember that that is talking about starting at a and then having this x vary, that would be our area under the function, that function is an antiderivative of the integrand. That means if we take the derivative of this integral, we're essentially undoing whatever the integral did. So derivative and integral are inverses and they undo each other. Now notice the variable name was t here and we were integrating with respect to t, but the function was a function of x because of this top number being an x. So when I take the derivative, I'm taking the derivative with respect to x, this variable ending point of our interval. So when I take the derivative, I'm simply replacing the t values in the integrand with x's. Now this is a problem that we could actually just solve explicitly in 2 steps. So we could do the integral. The integral of sine of 2t is negative cosine of 2t over 2. So antiderivative of sine is negative cosine, and we did just kind of a little bit of a chain rule undo there. And using fundamental theorem part 2, we plug x into the top one, and actually that should be a 1 into the bottom one. For some reason I had 0 in my head when I was writing these notes. So this should be a 1. That's not a half, but in any case it's some constant. So this is cosine of 1 divided by 2. Then we go ahead, that's my g of x, and we take the derivative. So the derivative of that, derivative of negative 1/2 cosine of 2x would be negative 1/2 negative sine of 2x times 2. The derivative of this constant is just 0, and you just end up with sine of 2x, which is your original integrand, but with the t's replaced with x's. So if it's as simple as an integral from a to x, and then you're asked to find the derivative of that integral, it is simply the integrand with the t's replaced with x's. Things get a little bit more complicated when we have an area so far function that doesn't vary linearly with x, so it isn't just an x right up here. So in this one we have sine squared of t cubed, and we're integrating from 1 to x squared, that's my g of x, and we want to find g prime of x. So what I like to do for these problems is I like to call my integrand little f of t, and I don't actually need to know the antiderivative. In fact, this function does not have a nice closed antiderivative that I can find. I just need to give a name for the antiderivative. So I'm going to give the antiderivative the name capital F of x. So the integral from 1 to x squared of this integrand is just capital F at x squared minus capital F at 1. So that's fundamental theorem of calculus part 2. I'm asked to find the derivative of this function, so d dx of capital F of x squared minus capital F of 1. So by the chain rule, that would be capital F prime of x squared, that's the derivative of the outside at the inside, multiplied by the derivative of the inside, minus f at 1 is just a constant, so its derivative is 0. Now capital F prime, we said f is an antiderivative, capital F is an antiderivative, so its derivative is little f, with x squared replacing all of the t's. So this is little f of x squared times 2x, which is sine squared of the cube of x squared times 2x, or 2x sine squared x to the 6th. Part C is similar in that it's not just an x, and furthermore, it's on the bottom of my interval instead of the top. We could flip it around and use the negation property, but I'm going to just do the same approach. I'm going to say g of x is capital F at 0 minus capital F of 2x, where this capital F of x is whatever this antiderivative is. Again, I don't need to know the antiderivative because in the next step I'm going to take the derivative of the antiderivative. So g prime of x, derivative of a constant is 0, Derivative of capital F is f prime at 2x times 2. That 2 is from the chain rule. The derivative of capital F is lowercase f. So f at 2x means take this function, secant of t to the fifth, and plug 2x in for the t's. And then we just simplify a little bit, reorganize, so this becomes 32x to the fifth, and then the 2 comes to the front. So if you're just taking the derivative of a regular area so far function, so you're doing d dx of the integral from a to x, f of t dt, that will just be f of x. But if you were taking the derivative with respect to x from a to, let's call it a u of x, f of t dt, you're going to end up with f of u of x times u prime of x. And that's just from the chain rule, because this was not just an x up there. So this was actually considered to be a composite function, so when I take the derivative of this integral, which is a composite function, I need to find its derivative using the chain rule.